Okay, so in this case we have an opportunity where we need to set up with our 0 point at the center of this cylinder here, which represents a pit. And we need to read out in degrees from the center of this pit, with this being the origin. And so the purpose is that the gun needs to be reading out with this as 0, and then the operator needs to set up something in 3.5 degree increments all the way around. So this is a good opportunity to use constructing a new frame and setting that as the working frame, and then using a watch window on the instrument. So let's start doing that. In this instance, in this pit, there is actually a center point located, a monument in the center of the pit, and also another monument or something located along the x-axis. So that'll help us to orient our frame when we construct it. So imagine we've already measured this point and we've measured another point along the x-axis. So what we're going to do is go to construct frame, and we're going to use working frame orientation, because we already have a level frame here built, and you can do that with this instrument. We're simulating a TDRA 6000. You can create a level working frame from within the instrument. So we're going to use that level working frame rather than trying to find a positive Z point. We'll just use a level working frame. So we're going to construct frame using working frame orientation, pick origin and clock X. So that's our origin, and this is our X. We're going to make that our working frame, and we're going to call it sat created. All we have to do now in order to see our 3.5 degrees read out from this is just place a watch window on the instrument itself. You can see right now I'm in Cartesian coordinates, but we'll just use that as an example just for reference. So this should be pretty close to y0, with green being y, and x being 98, which just happens to be the circumference of my cylinder that I created. So now in this orientation, x is 0 and y is 98. And the only reason that I'm using these points that I constructed on here is I'm not attached to a physical tracker. So this would be the same as if you were just pointing the beam at this location, or if you were using reflectorless, or if you were just locating the reflector. This would be a live readout of exactly where your target is with respect to this origin and frame. So as you can see, as I rotate further around here, if I were to bring it around now, I'd be at y0 and x minus 98. But what you really want to see is your cylindric coordinates, and that's simple by right-clicking on the watch window here and switching to cylindric. And in this case, r is representing the distance from origin. So if I go back over here, that's going to be r equal to 98. Theta is the angle that starts with the x-axis and proceeds all the way around to 180 degrees. And then z is your z height. So z is and r are in units length, and theta is in angle degrees. To the bottom of this, you'll see my z drops down to -56, but with this one will be at 0 because that's at the same height. And then you will see all the way around as I follow my either reflectorless or a reflector target, this is 0 and it's giving us an angle all the way around. So that is how to set up a new frame at the center of your cylinder and use that as the working axis, and then set a watch window on your instrument.